Welcome to my video lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikare, Dharmaburi. In this video lecture from upcoming semester Thermal Engineering 2, Unit 4 Cogeneration Waste Heat Recovery System. As you previously we have discussed about the Module 1, Module 2, Module 3, Module 4, Module 5. Module 4 and 5 we have discussed about the waste heat recovery system. From that Module 4 introduction of the waste heat recovery system, Module 5 we have discussed about the recuperators, recuperator heat exchangers, how to utilize the waste heat for preheat the air. From the Module 6, a very good interesting topic, that is a heat pipe and heat regenerating heat exchangers. From that regenerative heat exchanger it is used for the thermal power plant or whatever the gas power plant is very good regenerative heat exchangers, or more commonly a regenerator is a type of heat exchanger where the heat from the hot fluid is intermediately stored in a thermal storage medium before it is transferred to the cold fluid. To accomplish this, the hot fluid is brought into contact with heat storage medium, then the fluid is displaced with the cold fluid which absorb the heat. In the regenerative heat exchanger, we have to increase the efficiency of the furnace. The fluid or either side of the heat exchanger can be same fluid. The fluid may be go through the external processing setup and then it is flowed back through the heat exchanger in the opposite direction for further process. Usually the applications will use for the process cylindrical or respectively. From the regenerative heating was the one of the most important technology developed during the industrial revolution. When was used to the hot blast furnace or blast furnace, it was later used in the glass and steel making to increase the efficiency and open hearth furnace, and in high pressure boiler the chemical and other application where it continues to important today. From that nowadays we have to regenerative heat exchanger is important for that blast furnace and hot blast furnace, and also to increase the efficiency of the open hearth furnace. It is very useful application for that chemical industries and steel industries and cement industries. The regeneration which is preferable of large capacities has been very widely used in the glass and steel melting furnace. Important relaxation exist between the size of the regenerator, time between on reversal, thick of the brick, conductive of brick, heat storage ratio of the brick. So generally the regeneration heat exchanger is used for the glass industries and steel industry to melting the furnace. It is useful for applications of that furnace for glass ore or steel ore, to melting this ore, to maintain the thickness of the brick, conductivity of the brick, and the heat storage of the brick from the regenerating size. From this regenerator, the time between the reversible important aspects, long period would mean be high thermal storage and hence higher cost along the long period, and the reversible result in the lower average temperature of the preheat, consequently to reduce the fuel economy. Accumulation of the dust and the slagging on the surface of the reduce the efficiency, the heat transfer from the furnace. Next slide we have discussed about the schematic view of the regenerative heat exchanger. From that heat exchanger we have to use this type of furnaces using for steel industries and glass industries. So we have to increase the efficiency of the furnace, and also we have to, if you have any lag or it will be used for the mud is present on that area means, so they have to increase the life of the furnace if you using this type of regenerative heat exchanger. Next important topic is heat pipe. From that heat pipe is a heat transfer device that combines the principle of both thermal conductive and phase transition to effectively transfer heat between the two solid interfaces. From that heat pipe can transfer up to 100 times more thermal energy than copper, the best known conductor. In other words, the heat pipe is a thermal energy absorbing and transferring system and have no moving parts and requires minimum maintenance. All the hot interface of the heat pipe as a liquid contact with thermally conductive solids, surface turns into vapor absorbing heat from the surface. From that heat, thermal effective thermal conductivity varies from the heat pipe length that can approach 100 kilowatt for long heat pipes, in comparison with approximately 0.4 kilowatt from that copper pipe. From that figure we can detailly study about the heat pipe mechanism. From here the heat pipe mechanism is used for various application. From the process of heat pipe thermal cycle, from the process 1, the working fluids to evaporated absorbing the thermal energy. From here the evaporator to absorbing the thermal energy from the process 1. From process 2, the vapor will be migrated from hot body to cold body, from cavity to lower temperature to from the hot fluid is going to the lower temperature. The third condition is from the vapor will be condensed back to the fluid and it's absorbed with the help of the wick to releasing the thermal energy. Again that fluid is recirculated, goes to the hot body, means with the help of the wick the fluid will be transferred from the with the help of that wick the fluid is going to the hot body. Fourth one is the fourth process is the working fluid flows back to the higher temperature end. It is a repeatedly recycling process from hot body to cold body to hot body to cold body. With the help of the wick, there is a two section is showing from here. One is a from the left hand side higher temperature section, from the right hand side lower section. From here the environmental temperature is going. From that insulation is very important from the heat pipe, because of the escaping of the heat is very loss will be happen. So the insulation is very important from that heat pipe. From that heat pipe we can see that cross sectional view of the heat pipe. From here there is a four section. One is a first section is adiabatic section, second section is condenser section, third section is wick, fourth section is evaporator. From that adiabatic section, from the vapor will be traveled from the evaporator in the condenser through the adiabatic section. As the pressure drop is low, there is a little temperature changes in this area. After the fluid is going to the condenser, with the help of that wick we have to cool the heat is exit from the heat pipe at the condenser, where the working fluid condenses and less latent heat of vaporization. The condensed working fluid is down back into the force to wick for the return to the evaporator. So from here we have to using for water, and also nowadays we have to using for various application, and a lot of research is going on from the heat pipe because of using for that cryo from the aerospace applications to reduce the heat from that aerospace application. It is very useful for heat pipe is used for that aerospace application. And also nowadays we have to using for the nano fluids also using for the heat pipe to find out the better efficiency. Next slide we have discussed about the performance and advantage. From here the heat pipe exchanger, the lightweight, compact and heat recovery system, it is virtually does not need to mechanical maintenance. There is no any moving parts and wear and tear. It is does not need input power for its operation, and it's free from cooling water and lubrication system. It is also lower the fan horsepower requirement and increase the overall thermal efficiency of the system. The heat pipe heat recovery system is capable operating for around the temperature of 350 degrees Celsius. We get the recovery from the percentage level 16 to 60 to 80 percentage. From this slide we have discussed about the structure and design and construction of the heat pipe. From that heat pipe we can three types. One is a sintered, grooved and weaved. From this typical heat pipe is consist of sealed pipe or tube made of a material that is compatibly with the working fluid, which a copper for water heat pipes or aluminum for ammonia. From copper for water heat pipes, from aluminum for ammonia heat pipes. Typically vacuum pump is used to remove the air from the empty of the heat pipe. The heat pipe is partially filled with working fluid and then sealed. The working fluid mass is chosen that heat pipe is contain both vapor and liquid for operating temperature range. From the structure and design and construction, the typical heat pipe consists of sealed pipe made up of material compatibly with working fluid, such as copper for the water heat pipes and aluminum for the ammonia heat pipes. Below the operating temperature, liquid is too cooled and cannot vaporize into gas. Above the operating temperature, the liquid has turned to gas and the environmental temperature is too high and any of the gas is condensate. From the heat pipe, materials and working fluids are used from the heat pipe. Heat pipes have envelope wick and working fluid. The heat pipes are designed for very long term operation. There is no maintenance, so the heat pipe well and wick must be compatible with the working fluid. Some materials or working fluids or pairs appear that compatible or not. For example, water is an aluminum envelope will develop the large amount of non-condensable gas over the few hour days. preventing normal operation heat pipes. Since the heat pipes are rediscovered by George Groover in the year of 1963, extensive life test has been conducted for the determination of compatible envelope fluid pairs. Some going for decades. The heat pipe life test heat pipes are operated from the long periods of time and monitored for the problems non-condensable gas generation, material transport and corrosion. Mostly commonly used for the envelope and wick fluid pairs are included. Copper envelope with water fluids or electronics cooling. This is by far for the most common type. And also copper and steel envelope from the refrigeration application for heating and ventilation and air conditioning system, and aluminum envelope with ammonia working fluids or spacecraft thermal control, superalloy envelope alkali materials cesium potassium sodium working fluids are high temperature heat pipe, mostly commonly used for the calibrating the primary temperature. Because of from here the heat pipe we have to using for the nano fluids are using for other pairs of include the stainless steel nitrogen oxygen neon hydrogen and heliums also working fluids to operating the temperature of the 100 kelvin. Copper and methanol heat pipes are electronic coolings with heat pipes must operate the water range. Aluminum and ethane heat pipes are using for the spacecraft application, and ammonia can be freeze from the refractory metals and lithium working fluid and high temperature because of 1050 degrees Celsius from this application. You can use this. These are all the materials and these are all the fluids are using for the heat pipe materials and working fluids it for efficiently to operating for this type of from the heat pipe applications. From the different types of heat pipes are present from that market. First one is a vapor chamber, that is a planar heat pipe which are used for the heat flux transformation and isothermalization process. Second one is a variable condensation heat pipes which is used for non-condensable gases and change the heat effective thermal conductive as per the heat sink condition changes. Third one is a pressure controlled heat pipes which are VCHP where the volume reservoir, and next one is a diode heat pipes which have the higher thermal conductivity in the forward direction and lower thermal conductivity in the reverse direction. Next one is a thermosiphons which are the heat pipes are which are returned to the evaporator and gravitational acceleration process. Next one is a rotating heat pipes which are liquid is returned to the evaporator by centrifugal forces. And application is very essential for the spacecraft. From that spacecraft we have to using for this type of heat pipes are used grooved wicks pipes and typical grooved aluminum ammonia variables are this type of heat pipes are used for the spacecraft because of more heat more electrical components are used for the applications of satellites and also for from the satellites and rocket propulsions we have to extract the heat from that applications. And also from it is used for the computer systems. The heat pipes are became used for the computer system in the late 1990s when increase the power requirement subsequent increases heat emission resulted in the greater demands in the cooling system. There are four extensively used in the many modern computer systems typically to move heat away from the components such as CPU and GPU and heat sinks where thermal energy may be dissipated into the environment. From that computer application, for example, in your laptop, you can using that fan and other application. And also, if you not operating the fan means your system is not operating because of microcontroller and microprocessor are operating from high temperature. So that's why we have to recover the heat with the help of that heat pipe because of from that CPU central processing unit and GPU we have to using that heat will be record goes to the sink condition. So from that heat pipe is very essential for the spacecraft applications. Next slide. Various application for process of space heating, process to process and heating and ventilation and air conditioning system, and heating to recovering from the boiler combustion air waste heat furnace and fresh air from the hot air is entered. Various application we have to using for the heating application. First two technologies we have to recover the waste heat from that useful applications. Next slide we have discussed about the case examples of the heat pipe. Can using the casing system from the hospital cooling system for to recover the heat from that hospital cooling system. Thank you.